morning, sir.
Good morning, sir.
Okay, so today's session. Today, our second is come on. In. So first of all, it's problem we about the like that, and further we uh, I get a question. It will be possible to discuss the level shape file. Basically, you have to get the level shape file. Okay, can you hear me now? Yeah. Okay, so is it clear now? Can you hear me?
Yes, sir. Yes, sir.
So it will be possible to show the CD file. Not it. So further, some zip file is available. Suppose you can easily get the Google Activity platform, and some zip file is not available. For that, we have to get this type of zip. Suppose when go to the GIS this website, you find out some zip file. But when you want to go to the more regional or more local area, then you have to create this file in ArcMap or QGIS software. Then you have to put it that in the platform. Okay. So let's go try to start. So here you can see one kind of data set. So basically, it's another data set. Mainly using this data set, we can easily get that global administrative unit layer, a first level administrative unit. Okay. So here you can see this is the data set. It will provide you the different types of cities or division wise shape file. We can get the districts. So here you can see the global administrative unit layer compiles, and this data set is that available information, but that we can easily get from the administrative level, mainly district. Okay. And data set is provided only for the local region level from district. So we can easily get it for whole of the global data set. Okay. And here you can see how I can filter this data set. First of all, it's our feature collection. Okay, it's our data set. So this data set I want to filter. How I can filter? So administrative level 0 equal India, and administrative level 1 basically admin 1 name. We can put any name. Okay. Then it will also show about this type of boundary about this. Suppose in this time I put the Maharashtra, so that we can easily get that Maharashtra boundary. So any region. Suppose I just put here any other. Suppose I want to say about that Karnataka. So for that, I can write the name. So now we can get this boundary shift. Okay. So administrative level 1 we can easily get from here for any country in the world we can easily get it. Suppose I take some region for Bangladesh. Just I put at this Bangladesh and put here. Suppose I want to say about that Bangladesh. There, now let's see. So now we can get that Rangpur division. Basically, division we can get from here. So any suppose I put here that Rashtra, then I can get the Rashtra boundary from this data set. But when you want to work for the more local cities, suppose you can see the Nauga, Bogura, Pabna, Nator. So this type of cities, you also try can see what happens. The null, the data. Suppose I put here the Nator. In this time, you can see it show the cannot read properties of null. In this time, it's not available. This city. Suppose I need only for the Nator city. So what can I do? For that, we have to create the shapefile in ArcMap software. Okay. So how we can get this shapefile? Suppose I simply open my ArcMap, and from this ArcMap I can easily create this type of series shapefile. Okay, which is not available this type of data. So basically, this data at least provide you the data set from administrative level 1. Okay, only district or division. But when you want to go to the more cities, then we have to create it from ArcMap or use it. Then we have to use it. Then we can easily get it. Okay. So here you can see it's our ArcMap here. So time you have to download the shapefile. Suppose I need this type of Sri Mangal city or Moglo Bazar city. or Kulaura city or any other city. So for that, what can I do? First of all, I simply import my shapefile. Suppose I already download the shapefile from Diva GIS. Fine. This time I simply open the level 3. Okay, level 3, because level 3 is the city level for Bangladesh. Just I simply open it, level 3, in my ArcMap software. Here I can say I can get all of this boundary also. Suppose I want to show the another city. So I want to show the level of all of this. So go to the properties, and from here just I see the level, and go to the level. I click on the level feature there, and also set the level for 3. Okay, 3 mainly city Bangladesh. So then apply and OK. Now all of this get comparison. Suppose I need only for this city, for that, suppose Moulovibazar or Kulaura or any specific. So what can I do? So first of all, or select Shodor. Okay, so we try to select Shodor. So for that, you can simply click on the lasso tool and then click on this select Shodor. You can select this boundary. Now further click on here and go to the data, export data, and you can simply choose your specific folder where you put things. Suppose I want to put the desktop data folder. I put this name, it's a set. You can put any name, and shapefile. You can put the shapefile in here and save it. So then also save. Okay. And I want to add this layer. So now I create this select Shodor boundary shapefile. Okay. So now this city shapefile I just import in my Google Earth Engine platform, and then I can easily work with that. So you can see the data folder. I create this shapefile in here. I put the name is a select. Here you can see the select. Okay. Mainly in this time you are just simply imported SSP, SSX, then PRG and DBF. Okay. This 4 file, when you import in Google Earth Engine platform, then we can get the select Shodor city boundary, and then we can easily work with that. So basically this is the process about the city, which level or which boundary is not available in Google Earth Engine dataset. Then we have to get this type of things. As well as in ArcMap shapefile, you can also create the boundary shapefile. Okay, suppose you can easily create the shapefile. So let's go ahead to show you the example about that, how we can easily create the shapefile. So for boundary shapefile, I simply open a base map. Okay, so just I simply add a base map. Suppose then we can easily create the boundary shapefile. So for that, just I simply open a topographic map, and we are just digitizing our area, and then we can easily make a shapefile, and this shapefile we can also use it in Google Earth Engine platform. Okay, you can also check some shapefile or some local region is not available. Okay, so for that we are just applying this process, and then we can easily make the shapefile. Suppose in this time I simply add my base map. Here I can get this type of things, and from here, okay, I also make more zoom. Suppose this is my area about the shapefile. Suppose this is my area. Okay, this is my district area or city area. Okay, just I simply digitize it and then make this shapefile. So for that, I simply click on the catalog. In the catalog, I just simply choose a folder. Suppose I want to create the shapefile in the data folder. Just click on here, and then further click on this shapefile. Here you can see about the new. I want to create the new shapefile, so click on the new shapefile, and further I want to create the point, polygon or line. Okay, so basically we already know about that vector feature can be point, line, polygon. So in this time I want to create the shapefile for polygon, mainly boundary I want to create.
So for that, I simply click on that. You can see the polygon, okay, as well as you also add the special reference, okay. Mainly we have to set the coordinate system. So just you can simply click on the edit, and I want to set at that projected coordinate system. Suppose I set at that world WGS 984, okay. So WGS 9084, I simply select and okay, and then further okay. So now you can see it added the new shape file in here. So now further I just click on here and then start edit feature. So label feature, you can see the edit feature. Start editing, we simply click on here. Okay, it opening. So further you can simply click on the shape file, and here you can see the polygon, okay. Different types of construction tool you can set. Suppose I set the polygon. So now you can simply digitize your boundary. Suppose it's your boundary or village boundary or your anything. So in this time I take the randomly. Suppose this is my study area, I simply take the randomly. Okay, when you want to work for the small city or a small boundary, you can take the properly your study area. Suppose this is my study area. Okay, I take the randomly and I finish it. So this my, suppose this is my boundary area. Okay, after doing these things, you are just simply click on here and just stop editing, and you want to save it. Yes, I want to save it. So now it will be saved. Okay, so now it's create a boundary. So now further you are just simply click on here, and you can see the export data, and from here you are just simply choose a file. Suppose I put this shape file name is that, suppose random boundary, you can put any name and then save it. Okay, so now this shape file is saved, random boundary, and it's a geo-referenced. Okay, so when you want to work with the ArcMaps Google Earth Engine platform, we get the geo-referenced. Okay, there is no problem. So here you can see now it will be also added the random boundary. Okay, so you can simply select the SSP, PRJ, DVF, and also SSX. Just simply import, then you also get the very local region boundary shape file. Okay, so this is the process. Suppose some shape file is not available, then you can easily create this type of shapefile and work with the Google Earth Engine platform. And which shapefile is already available, then you can simply clip and then work with that. Okay, so I hope you can got this idea. So anyone, any question for the previous class or any doubt? Okay, I think there is no doubt. So we now will go to our next class, or I just open this course content. So basically today's session I try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat and Sentinel, and how we can easily use the different types of satellite composite, how we can easily use the different types of band combination, and how to export the satellite imagery, mainly Landsat, Sentinel, or MODIS, how we can easily import, filter, reduce, clip, and display the raster data in Google Earth Engine, and how to make the time series chart of NDVI or any other indices using Google Earth Engine, and as well as how we can easily export the any shape file from the Google Earth Engine platform. So let's go. Just I simply open my slide. So we already know about the Earth Engine public data catalog, and in this Earth Engine public data catalog we can easily access lot of remotely sensed data. It can be Landsat image, it can be Sentinel satellite image, it can be MODIS satellite image, different types of land cover data, atmospheric data. There are a lot of data so we can easily access from the Google Earth Engine public data catalog. And using the Earth Engine public data catalog, we don't need to download any types of satellite imagery, as well as we don't need to download any types of other remotely sensed data. We can easily access everything from the Google Earth Engine platform, and we can easily use it for the different types of analysis. And this data set is the updating daily. Okay, and Earth Engine public data catalog, basically this is the link about the Earth Engine data catalog. When you can simply go to this link, we can get all of those data set, and then we are just need to filtering this data set and also work with that. So let's go, we try to show you the example. Suppose I want to filtering and visualizing the satellite images in Google Earth Engine platform. When you want to filter the satellite images in Google Earth Engine platform, basically it's different on some factor. This filtering process is different, mainly three factor. One factor called as a region. Okay, suppose which region you want to need this satellite image, so it's very important. So first factor is the region. Second factor, it's called the image metadata. Suppose I want to need only for this image, which image will be not more than 1% cloud cover. So it's the another factor for filtering. Third factor, it's called the time period. Suppose you need the image for year of 2017. Okay, you need the image only for the summer season. You need the image only for the rainy season, or any specific season, or seasonal image, or annual image. So mainly when you want to filter the image collection in Google Earth Engine platform, it depends three factors. One is the region, mainly which area you want to need this satellite image. Second, you need to filter the image metadata. Suppose I want to need only for this image, which image will be not more than 1% cloud cover. So it's the another factor. And you also need the image for a specific time period. Suppose you need the image for year of 2017, or you need the image for rainy season, summer season, or any specific time period. So now let's check. We are just applying the three factor and then filter our satellite image collection. So how it will work, we show you the practically. Just I open a code editor. So first step, we have to simply go to this, you can see browse data catalog. So basically when you want to go to this link, it will be open this link. Okay, developers google.com Earth Engine dataset. Here we can find out all of those dataset. So in this time I want to work for the suppose Landsat image collection. I click on here. So here you can see you can get all of those Landsat image collection, mainly Landsat 9, Landsat 8, 7, 5, 4. I can get the different time period about that. You can see Landsat 9 is available from year of 2021 to present, Landsat 8 2013 to present time, Landsat 7 this time. Also you can see Landsat 5 this time is available, Landsat 4 this time is available. Okay, Landsat 4 this time is available. Okay, so mainly all of those image collection is the same for filtering process. Okay, so now let's check. Suppose I want to work for the Landsat 8. So click on the Landsat 8. So here I can get the different types of image such as surface reflectance. We can get the top of atmosphere and also got the raw image. Okay, so in this time, what is the difference between this type of image? So raw image, mainly in this time, this raw image, there is no correction such as atmospheric correction or enhancement. There is nothing about that. It's just a raw image. Okay, But when we work for the surface reflectance or top of atmospheric, so this type of image it is atmospherically corrected. Okay, so that's why in this time when I want to use this type of image, I don't need any kind of atmospherically corrected. I don't need, because this imagery is already done for, you can see, atmospherically corrected surface reflectance is already done, and this image is the calibrated top of atmospheric reflectance. Okay, and here you can see raw image. So basically this raw image is the totally raw image. Suppose there is nothing correction, but this type of image is correction already done. So that's why when I want to use this type of imagery, then we are also get the more better image, because it already atmospherically corrected, and it also already calibrated top of atmospheric reflectance. So that's why all time we are using this type of two sensor. Basically this image used for that land use land cover classification, as well as also used for LST monitoring, mainly land surface temperature monitoring. Okay, and basically top of atmospheric mainly it's used for calculate the different types of indices. Okay, so let's go. So both of image is the same process for filtering. So I will show you, suppose surface reflectance. So click on here. Here I can get this type of information, dataset availability. Mainly we can get the data from year of 2013 0318, from 2024 03404. Okay, so and it also updating daily. And this is the dataset provider, mainly USGS, Earth Explorer. Okay, and you can see Earth is a snippet. Basically it's a unique ID. Okay, it's a unique ID of this dataset. Every dataset we will find some unique ID. Okay, so this unique ID mainly we are used for importing the image collection in our code editor. So now this is my dataset and this is my code editor. Okay, so now this dataset I need to import in my code editor. So how I can import? Very easy. Just you can simply copy this unique ID. Simply copy this unique ID and then paste on your code editor. Okay, so now it will be show this type of things, and now give a variable name. Okay, just put a variable name. Suppose I put the variable name, you can put any name. Suppose I put the name is that Lancet. Okay, so here you can see this is my image collection. This image collection I just create a variable. I put the variable name is the Lancet. You can put any name. I put the variable name is the Lancet, and before the variable name we already know about that we have to must use the var keyword. Okay, it is a constant, but for the Python this var is not need. Okay, so in this time this is the variable Lancet. This variable is stored my image collection. I want to check how many images are available for the whole world between the time period year of 2013 to 2024. How many images are available? I want to check it for Lancet 8 image collection. So let's go. How I can check it? For checking these things, just use a function, print function. I want to print this Lancet size. Okay, so in this time I simply call the Lancet because this variable Lancet is stored my full image collection. Okay, so I want to calculate how many images are available, what's the size. So for that I simply call my Lancet and use the size function. Basically this size function calculated how many images are available. So now click to the run. So now it computing how many images are available for the whole world between the year of 2013 to 2024 in Lancet 8 image collection. Okay, so here you can see we can get the entire large number of image collection, more than 1 million image collection you can get from here for the whole world between the time period year of 2013 to 2024. This time period we can find out this number of image collection for the whole world. But in this time I don't need for the whole world image collection. I need for the specific boundary, suppose a specific city or a specific location. I don't need for the whole world. So for that, what can I do? For that, first of all, I just simply import my shapefile. So I already import my Dhaka city shapefile. Suppose I want to need the image, suppose for Dhaka city. So just I simply click on here. It will be imported my region of interest, my shapefile, which I already uploaded in my asset tab. And previous class I already show you that how we can easily upload our own shapefile. Okay, so let's go. Just I simply put the shapefile variable name as a ROI. Okay, you can put any name. So now my shapefile is stored in the ROI. So in this time, this image collection for the whole world, but I want to need the image collection only for the Dhaka city. How many images are available in the Dhaka city? So for that, in this time, I want to just intersect this whole image collection. From this whole image collection, how many images are available in the Dhaka? I want to check it. So for that, I just take a variable, suppose filter region. Okay, so now from this large number of image collection, how many images are available for my study area in Dhaka city? I want to check it. So for that, I simply call the Landsat, because my full image collection is stored in the Landsat. Okay, simply copy the Landsat and paste here. From this Landsat, how many images intersect with my study area of Dhaka city? So for that, I use a function, this function called the filter bounds function. Okay, so basically this filter bounds function intersect the whole collection with my study area in Dhaka city. And you can see what is the argument about that. This argument is the geometry, mainly your boundary. In this time, my boundary variable name is the ROI. So just I put here the ROI. So now it intersecting with the ROI. Okay, so here you can see Landsat. Basically, it's my full image collection. This full image collection I want to intersect with my study area. So now only which image in the intersecting with my study area, it will be stored in this variable filter region. So now let's check how many images is available in the filter region. We check it. For that, we are just use a function print and call the filter region, and then calculated the size, how many images are available. So now click to the run. In this time, we can got 434 images, and these 434 images are available in the Dhaka city. What's the time period? 2013 to 2024. This time period in Dhaka city, how many images? 434 images we can find out. So now from 434 images, I want to choose only for those images which image will be not more than 1% cloud cover. In this time, I filter my image properties or image metadata. From 434 images, I want to choose only for those images which image will be not more than 1% cloud cover. So let's go how we can easily filter. So just take a variable. I put the variable, you can put any name as a variable. I put the name, suppose filter metadata, and from 434 images, and this 434 images is stored in a variable. What's the variable name? Filter region. I simply copy this variable name and paste here. Okay, so from 434 images, I want to choose only for those images which image will be not more than 1% cloud cover. So for that, I just simply use a function, this function called the filter metadata. Okay, so basically this function used for filtering the image properties such as cloud cover, land cloud cover, So in this time, you are just simply check what is the argument about that. You can check about the argument. You can see name, operator, and value. So what is the name? Name mainly image properties name. You can see about the image properties. You can see the cloud cover land. So there are a lot of properties and different ways we are using the different types of properties for the different types of analysis. So in this time, I choose the cloud cover. Simply copy cloud cover. I just put the name in here. Name is the cloud cover, and I set the operator such as, suppose in this time I put at the less than, and set the value. Value is the 1. Okay. So in this time, from 434 images, mainly filter region, it started the 434 images. From 434 images, I choose only for this image, which image will be not more than 1% cloud cover. So just I call the filter metadata and put here the cloud cover less than 1. So now let's check how many images are available in Dhaka city which is less than 1% cloud cover. We have to check the size. So for that, just use a print function, print, and call the filter metadata, and use a function, size function. Click to the run. So now you can see it computing how many images is the less than 1% cloud cover. We find out 63 images is the less than 1% cloud cover. So now let's check how many images for the 5% cloud cover. So click with the 5, less than 5%. In this time it also increasing. We can get the 111 images are available for the 5% cloud cover. You can check the 10%. Okay. So now this number is also increasing. When I increase the cloud cover level, this number is also increasing. We can get the 144. So in this time I choose only for the less than 1% because I choose the very less cloud cover image for my study area. So I want to put here the less than 1%. 1% I find out total 63%. Sometime when you want to work for the coastal area or river bank, then you did not find out the 1% is the 0 image. Okay. Suppose you want to work for the coastal area. So then the less than 1% is not available for this study area. Okay. You are just put at the 1, but you did not find out any image because for this region less than 1% image is not available. So that's why I find out the 0. Then you have to increase the level of the cloud cover. You have to check 5% is available or not, 10% is available or not, 20% is available or not. You have to check it. Okay, then you have to work. Basically in the coastal region or coastal area or river bank is not possible to get the less than 1% cloud cover because they are have all time they are make the condensation or cloud formation. So that's why all time they have the cloud. So that's why it's very difficult to find out the less than 1% in the cloud in the coastal area or river bank region. Then you have to increase this cloud level. Then we also get the image and then work with that. So here I can get the Dhaka city, I can get the less than 1% image is a 63. And what's the time period? This time period is that year of 2013 to 2024. Okay. But in this time, I want to work for the specific time period. Suppose year of 2024, month of January. Or I want to work for month of January to March. Or January to February. Or any specific time period. Or year of 2018. Okay. So let's go how I can filter the time period. So for doing these things, we are just take the another variable. Suppose I put the variable name is the filter date. You can put any variable. From these 63 images, I choose only for the image which are available in year of 2020. Suppose I simply copy this filter metadata because this variable stored the 63 images. Okay, I simply paste here, and further I just use a filter date function. Okay. So basically it's filtering your specific time period and put here start date and end date. Okay. Suppose I put the start date mainly year of 2023, 1st January from I put the time period, suppose year of 2023, December 31. So now I can find out in the month year of 2023 how many images is available. So now let's check. So put here the print function and call the filter date, and then further use a function, size function. So now let's check how many images are available in year of 2023. We find out the total 7 images. Okay, so in this time, final step, we can find out the total 7 image collection for my study area in Dhaka city, and this 7 image collection is available in between this time period, year of 2023, and this 7 image is the less than 1% cloud cover, and this 7 image is available for my study area. So this is the process for filtering. First of all, we have to filter this where you need this image, where mainly your place, your study area, where you need this image. Using the filter bounds function, we define where. Then how I need this image. I want to need only for this image less than 1% cloud cover. How I define in using the filter metadata function. And then it's the when you need this image for a specific time period, where you use the filter date function. So all time when you filter image collection, it can be Lancet, Sentinel, Modis. All time we are just ask a question where I need this image. I need the image for the Dhaka city. So here I define using the filter bounds function. How mainly how I filtered this image less than 1% cloud cover. When I need this image, I need the image for year of 2023. So where, how, and when I use, and then I filter this image collection. First of all, you can see I can get the very large inter image collection. Okay, then I filter it using the where function. Where mainly where I need the image, and then how less than 1% cloud cover, and when I need this image year of 2023. So this is my entire large number of image collection for the whole world. I filter it for my study area in Dhaka city. I choose the only for the less than 1% cloud cover, and further I choose year of 2023. Okay, so any question you can ask me. Any question? So basically we are also use here the other method also, further I also try to discuss one by one. Okay, so as well as instead of the filter metadata function, we are also use here the other types of function. It also come one by one. Okay, so in this time I can get the total 7 images. Okay, so this 7 images, what is the properties about the 7 images? Is the less than 1% cloud cover, it's available between this time period, as well as this 7 images is available in my study area. So now I want to check what is the acquisition time period about this 7 images. Okay, so let's check. Just simply print filter date and then click to the run. So here you can see in this time I can get all of this information about the total 7 images. Here I can get the 7 element, it means that 7 images. So click on here, you can check the feature. So here you can see I can get the every images have total 19 bands. And what is the time you can get? The time is the mainly first image we can get the 18 January 2023, 7 March, 8 April, okay, 2nd November, 3rd February, 8 March, 2nd November. Okay, here you can get the different time, acquisition time, okay, for each images. And also click on here, you can get all of those band name as well as also property, image properties. Here you can see the cloud cover land, all of this information about the image we can get from here. Okay, all of this information here we can get about the single image. So in this time, suppose I want to work for the single images, single image mainly single tiles, only for the single tiles or single acquisition images. Suppose I want to work for this image collection image, so it's a single image. So I want to work for this image. Which image is the acquisition date is the year of 2023, 08/04/08 this time. Okay, I want to work with that. So how I can get this image and visualize this image in my map? Very easy. Okay, so it's called the single date image. So how I can get the single date image? Just take a variable. I put the variable name, suppose image equal sign, and then use a function ee dot image. Okay, and further we are just copy this id about this image. Suppose I need this single dial image, I simply copy this id and then this id paste here. Okay, so now further I display this image. So just use a function map.addLayer and call this image. Okay, and also focus the center of this boundary shape file. So use our map.center object. Suppose object is my boundary shape file variable name, which is ry, and also click to the run. So now we can get the image. You can see it will be loaded. Okay, so you can see it shows the tiles. Okay, so basically this tiles acquisition date is that year of 2023 0408. This time this is the acquisition date about this satellite image. But this satellite image, you can see it's not fully cover my study area. So how I can get this idea is not fully covered? You also add the layer of your boundary shape file. Suppose I just add the layer of the boundary shape file. So just use your map dot add layer and call my boundary shape file, which is ry. Click to the run. So in this way we can easily get the idea it will be fully covered or not. Here you can see. So this is my study area. Okay, and you can see this is my tiles about my satellite image tiles. But in this time you can see some place is not covered. Okay, this tiles is not cover my place. So for that, what can I do? For that, in this time you also change the tiles and check the other tiles which is fully covered, which is fully overlay with your study area. Just try to find out these tiles and then use it. Suppose I want to check the another tiles. Click on here and go to the feature. Suppose I want to check about the first tiles. What is the condition about that? Simply copy this id and these things I simply paste here. And now let's check what happened about these tiles. Is it really fully covered or not? We check it. Okay, it also not covered. Let's check another image. Suppose I check the second image. What is the condition about that? Simply copy. And then paste here. Now let's check again. It also not covered. We try this image. Copy and then paste. Okay, it also not covered. Let's try to check it. Okay, so it's covered, I think. Yeah, you can see now these tiles which is acquisition time is that it's cover my study area. So that's why I can use it for my research work or analysis. So in this time I just simply clip with my study area. Just use here the clip function. Clip study area mainly ry. So click to the run. So in this time it's just clip with my study area in Dhaka city. Okay, it's done. But it look like that because it show the default band visualization. So I need to set the band combination in this time. So how I can set the band combination? Very easy. Just simply, you can see the two layer. This is a boundary layer and this is your image layer. Okay, simply go to the image layer setting properties and set the band combination such as red, then green and blue. Custom 90-80% for better looking, and then apply. So now we can get this type of images. Here you can see. Okay, so now you can get this type of images. Not only for that, any kind of band combination you can simply set here. Suppose here infrared, then red, and also put at the suppose blue. 98% apply. So now we can get this type of band combination. Okay, as well as any kind of band combination. Suppose short wave infrared 1, then near infrared, and green. So you can use the different types of band combination from here. Suppose natural color, mainly it's called the red, green and blue. We find out the natural color. Okay, you can see. Just you are using this technique and you can put different types of band combination. And in this time, this visualization I want to import in my code editor. So how I can do that? Simply click the import. You can see a new line of code will be added. Simply copy the variable name and this variable name paste after the object name. So this is my object. I simply paste here. As well as I also put the layer name. Suppose I put the layer name, suppose single date. So now we can get this image look like that. So now we can easily use this image and create the different types of remote sense analysis such as land use, land cover, or NDVI map, or any kind of analysis you can easily do using the satellite images. So this is the process for single date image. But single date image is only available for that small area. But when you want to work for the big area, suppose you need the whole study of Bangladesh, okay, then single tiles is not enough for the whole country boundary of Bangladesh. Then we have to put the another way. We have to create the composite about this, all of this image collection. We can easily use here the different types of composite or mosaic, and then we can easily make this type of things. So in this time, it's a process for the single date because different types of analysis we also need to use the single date image collection. So you also try for the single date image collection. Okay, so in this time I talk about that how we can easily create the composite, mainly different types of composite, and then make the image. So for that I just show you that suppose in this time in the filter date it show the total 7 images. Okay, in this time I create the total 7 images median composite. Median composite means that it create the total all of the 7 images, make the middle pixel value, and then create this composite. So all of those 7 images in this time involve and then make this composite. So how I can use the median composite? So for that I just take a variable. Suppose I put the variable name is the suppose final image, and then call the filter date. Basically this filter date, it started total 7 images. In this time I use here the total 7 images and create the middle pixel value and then create the median composite. So for that simply paste here the filter date and use a function median. Okay, now it create median. Now it create the middle pixel value and create the composite and store it in this variable. So now I want to show this result. So in this time just simply use here map dot add layer and call the final image. Click on. So in this time you can see all of those styles combine with each other and make the median composite about that. So in this time I just simply commenting these things. Not need. Okay, just commenting, also commenting these things and click the run. So in this time we can get this type of result. Mainly it's the median composite all of those tiles, all of those tiles, mainly total 7 tiles. Okay, is make this type of composite. Okay, so now it's covered the full area of also about that. So now I just simply clip with my study area, just use a clip function, clip with the study area RY. So now click run. So now we can get the result only for the Dhaka city boundary. Okay, and this image mainly it's the create the median composite from total 7 images. Okay, so all of images create this composite. So now let's check about the visualization from here. Just click on here, and I want to set the most visualization is that red, green, and blue, and set stressing 98% for better looking and apply. So now we can get this type of median composite images. Okay, so this is the process for creating the median composite, and it's very useful for the big region. Suppose when you want to work with the big region, one tiles is not enough for covering the full area. Then we have to use the median composite and then fully cover our study area and then work with that. Okay, so this is the process about that median composite. So in this time, anyone any question about the full code, you can ask me. Okay, okay, I'll show you, no problem about that. In this time it show the 19 bands, but we can easily select our specific band. Suppose in this time here you can see median. So in this time it considering all of those images. You can see every channel have all of those band. Okay, total 19 bands. Every channel you can get total 19 bands. In this time, suppose I want to work only for the B1 to B7. Okay, this 7 band I want to use in here. So for that you can easily select. You have to also use the option for selecting. For selecting you can easily use a function. Suppose here so simply use a function I put here the select function, select, and select the all of band which I need. Suppose SR B1. Suppose I want to select here SR B2. Select here SR B3. Suppose SR B4. SR B5. SR B6, and finally SR B7. Okay, so now click to run. In this time we just take only for the 7 bands, and you can check about your channel. Suppose I just simply set here. In this time we can get only for the 7 band. You can see only for the 7. Okay, only for the 7, only for the 7, only for the 7, because in this time I choose my specific band. Okay, using the select function. So mainly select function we use for selecting our specific band. So now from here you can easily set the different types of visualization. Suppose I set here the SRB, suppose near infrared, then put here the red, and put here the suppose blue, and customize 98% stressing, and then apply. So now you can get the better visualization, this type of visualization, false color composite, band combination, and then import these things. Simply copy from here and add after the object name. I put the layer name, suppose it's a so in this time we can get this type of layer name in here. Okay, and you can simply select function and then select this type of band. Okay, so any question? Okay, so in this time we can get this type of result, and this is the process for filtering. And you can see I use here the lot of code in this time. So in this time individual function I take the individual variable name, individual function I take the individual variable name, different function different variable name I take. But if you want you can just take only for the one variable, and under this variable you can put all of those things one by one. So first time I show you the all of those things for your understanding mainly how it will be work. But next time when I want to write the code I just take only for the one variable, and under this variable I put all of those function. So let's check your example. So just I simply commenting all of those things, just commenting. In this time I take only for the one variable. Suppose I take the variable, suppose Lancet. Okay, and then all of those things I want to store it in here. So for that, first of all, I just use here the filter bounds function with my RY, then put here the filter metadata, cloud cover less than 1, then put here that filter rate, sorry, filter date year of 2023, that was 1st January, from year of 2023, suppose December 31. Okay, then further I simply use here the select function and put here that band name SRB1, SRB2, 3, SR4, SR5, SRB6, SRB7. Okay, and further I, in this time you can check about the, simply print the Lancet. Suppose I print this Lancet. Here I find out the final image, how many images is available for my final step. We can get, you can see we find out the 7 images. Okay, so in this time, this 7 images, if you want to work for the single image, just apply the same process which I show you. Simply copy this ID, and in this time you can see all of image the 7 bands, because I want to put my only for the 7 bands in here. So simply copy this ID and then work the same process for the single data image collection. Okay, which I already show you. Or if you want, you can simply make the median composite. So for that, just use here the median function, median, and then clip with study area. So clip with study is alright. So now visualize it. So just simply use here map.add layer and call this variable name Lancet. We copy and paste here, and then further I simply copy the previous visualization parameter variable name and paste here. Click on run. So now it will be loaded. Okay, just mainly we are using this type of code for you get the Lancet image collection and filter the image collection. Basically in this time we not take any individual variable name. Okay, so we are just use the same variable. So basically filter bounds function used for where you need this image, and filter metadata function used for how only less than 1% cloud cover, and this function will use for when. Okay, and basically it's used for selecting the specific band and median compose and clip with our shapefile. Now we can get this type of visualization about this thing. Okay, so this is the process for filtering and visualizing the satellite images in Google Earth Engine platform. And this satellite image we can easily export and then work with the ArcMap software or QGIS software easily. So let's go how we can easily export these satellite images from here. And before that, we also talk about the another data set, mainly this part, and try to show at the same time I will show you that how we can easily export these things. So in this time we talk about that how we can easily import the data set, mainly other data set, mainly MODIS. Suppose you can see how to import the data from Earth Engine data set, how to filter this data, and how to reduce this image collection, and how to clip on your shape file, and also how to display the result on the map, how to reproject it, the scale pixel value. So let's go try to discuss about this part, and then at the same time I try to show you that how you can easily export this satellite image and also other images. So let's go. Just I try to open a new code editor. and further go to this browse data catalog. And suppose I want to work for the modis. So basically modis provide you different types of derivative data sets, such as here you can see the daily product. So it's a daily product, mainly trap, vegetation, continuous fields, yearly, global, 250 meter resolution. So it's one kind of data set, vegetation. Also tra, land watermarks derived from modis, SRTM, yearly, global, 250 meter resolution. Tra ocean reflectance data set, 1 kilometer resolution. Aqua ocean reflectance data daily, 1 kilometer. Modis land use land cover data set. Okay. Also you can see we can get the modis land cover yearly global data set. Okay. Land cover dynamics yearly data set you can also get from here. So recently it's also updating, so that's why some new data set also added in here. Modis leaf area index data set you can see 500 meter resolution. Surface radiation daily 3-hour data set. Also you can see the photosynthetic activity radiation daily 3 hours data set. We can get the land surface BRF daily global 500 meter and 1 kilometer resolution data set. Terra and aqua aerosol optical depth, basically it also used for PM 2.5 making the 2M, it also use this data set. As well as also you can see the modis albedo BRDF data set, modis albedo daily data set, modis NDRBR. So there's a lot of data set for the modis. Also you can see terra reflectance data set, surface reflectance daily global data set, terra surface reflectance data set, terra surface reflectance data set, LST data set for daily global. Okay. 8 days global 1 kilometer data set, terra vegetation indices 60 global data set. So there are a lot of data set. Okay, so in this time I will show you this, suppose one data set, how it will be work for the modis. You also try use this data set and then try to make the other data set. Okay, suppose same process here, all of data set which you show for filtering, visualizing and mapping is the same, all of data set. Okay, suppose in this time I will show you this data set, terra vegetation indices 60 global 250 meter resolution. So basically this data set, I simply click on here, then I can get all of information about this data set. So basically this is the terra vegetation indices 60 global 500 meter resolution data set, and this data set mainly used for vegetation index at per pixel basis. And this data set, how they create this data set, you can see the information about that. And basically it also called the ready-made data set. Okay, ready-made data set, mainly this data set already have a band, NDVI and EVI already available. Okay, so that's why in this time we are not put any kinds of equation or formula or index formula, or we don't need to put in here. So it's called the ready-made data set. Okay, we in Google Earth Engine platform you can easily find out different types of ready-made data set and also use it. So in this time you can see this data set is very useful for monitoring the vegetation, normalize difference vegetation, and also enhance vegetation EVI. Okay, and mainly that minimize the canopy background and variation that maintains the sensitivity over the dense vegetation condition. And basically in this time for the surface reflections that have been masked for water, cloud, heavy aerosol and cloud shadow. Okay, it already masked. So that's why when I use this data set, this type of unnecessary pixel is not come, because it's already masked. We can get the very clear vegetation map using this data set. So now how I can use this data set? So very easy, just simply copy this unique ID and further paste in your code editor. Just paste here. Okay, then give a variable name. You can put any name. Suppose I put the name is a modis vegetation. Okay, so now this image collection is stored in this variable. This image collection have a 2 band. You can see we are learning about the NDVI and EVI. I want to work for the NDVI. Okay, so for that I simply copy the band name. This band I want to select, so just use a function select and select this band NDVI. Okay, Basically this image collection have a two band. From this I select only for the one band of NDVI. Okay, done. And this image collection is available between this time period, year of 2002 2024. This time period is available. It also updating, no problem. And in this time I don't need for the whole time period, I need only for the specific 1 year data. So for 1 year, how can filter? Very easy, just use a function, filter date function. So just put here filter date function and put the time, suppose year of 2023, 1st January, from year of 2023, suppose December 31. So this is my time period. So you can see, first of all I simply input my image collection. My image collection have a two band, so that's why I simply select a one band NDVI, and I want to choose the image for a specific time. Okay, so now this whole thing is stored in this variable. I want to check how many images is available for the 1 year. So just use a print function and call the Indices. Simply copy this variable name and paste here. Use the size function. Click on. So here you can see about the 23 images. Okay, we can find out the total 23. And where's the interval? Interval mainly you can see this image interval is the 16-day global. Okay, so this image is a 16-day global. It means that we find out the image interval date is the 16-day. Suppose 23 into 16, we find out almost 1 year. Okay, you can see, suppose 23 multiplied with the 60, we find out the 368. It almost covered the 1 year. So that's why in this time for the 1 year, I find out the total 23 images, because this interval is the 16-day. And also you can see about the 16-day, you find out some images the 8-day, 16-day, 32-day, or annual. Okay, so in this time it is a 16-day. So that's why for the 1 year I find out the image 23. So this is my image collection. Okay, so now I want to use this image collection and then work with that. So for that, what can I do? For that, I just try to show you this. Suppose map dot add layer and call this notice base and click run. In this time it loaded for the whole world. We can get 1 year NDVI map. It show this type of things, but I want to add the visualization. It also more better. Suppose I just you can see that already provide some color code in here. So just I copy their color code from here, and then further I use it in my code, paste here, and then copy and paste after the object name. Click run. So now we are also get the colorful map of NDVI for the whole world. Okay, so now it represented the year of 2023 map of NDVI for the whole world. We get this type of map. Okay, but in this time I don't need for the whole world. I need only for the specific country or a specific boundary or a specific shape file. So what can I do? You can simply import your boundary shape file and then import and work with that. Suppose I just simply click on here, table, it will be come in here. I put this name, suppose it's a RY. Okay, and further I want to use it. So in this time you can see what the problem. I just simply use here I take the variable, suppose NDVI map. I want to create from this total 23 images, and this total 23 images, when I clip with my study area, suppose ROI in this time, and also show these things. I want to add a layer about this map. Simply copy and paste here and click to run. In this time we can find out a problem. It showed that modis clip is not a function. Okay, so in this time it's my collection. Okay, how much collection? Let me show you that. It's a 23 image collection. Suppose I just paste here. So in this way we can get the collection is that 23 image collection. Okay, and when I clip the 23 image collection, then it show that clip is not a function. So what's the problem? Mainly when you want to use the clip function, then you have to reduce this image collection. Okay, you have to reduce, you must all time, not only for this data set, any kind of data set. Image collection, suppose in this time I find out the total 23 image collection and I want to clip this image collection with my study area, then it will be not work. It show the this type of things, clip is not function. Before using the clip function, you must make the single image. So now this 23 image is available. So this 23 image, I need to make a single image. So now what's the process and how many process I can use to create the single image? I have a total 23 image. So now this total 23 image, I need to convert into one image. So what's the process I can apply? In this time, I can apply, suppose I want to calculate the average. Suppose from the total 23 images, I want to make the average image. Or from total 23 images, I make the maximum image. From the total 23 images, I make the minimum image. So now how it will be work? Suppose in this time, I find out the total 23 images. From total 23 images, for single image, I want to calculate the mean or average. So from total 23 images, I make the average and make a one image. Suppose I calculate the average NDVI. Okay, so it's called the reducing the image collection. I have a image collection. This image collection I want to reduce, and there's a lot of use, a lot of different way to make the reducing. In this time, I want to use here the average. So how I can do the average? So let's go. Just take a variable. Suppose I put the variable name is that. Suppose average NDVI. Okay, and I want to calculate the average from 23 images. So just I simply copy the image collection and paste and make the mean function. Okay, after using the mean, I can easily use here the clip function. Clip with my study area, which is RY. And now further, I just simply copy these things from here and then paste. I want to load the visualization about the NDVI map for Bangladesh. So now I can see it will be loaded. And I also want to focus the center of the shapefile. So for that, I just use here map dot center object is that RY. Suppose 8. So now it view center focus of my map. Okay, you can see you can get this type of map. NDVI map of Bangladesh, year of 2023. So any country boundary, suppose you can simply import your boundary shape file, any cities or anything. Or if you want, you can also use this type of data. Previous class I will show you the one data set. It's called the DOS, basically international boundary polygon. Suppose I simply import these things, and further I simply filter my specific own country. Suppose just take a variable. I put the variable name, suppose RY, and then I call the table. Just filtering, earth engine filter equal country name. Suppose I choose the country name for suppose Pakistan. Okay, so in this time, what can I do? This is my international country boundary polygon. From here I choose only for the Pakistan boundary and instead the RY. Then I remove the previous RY, it not need, and now click the run. So now I can get the NDVI map year of 2023 for Pakistan. Here we can see the NDVI map. For any country, you can simply put the name, then we can get the result. Suppose I simply put here that Australia. So now we can get the NDVI map of Australia, year of 2023. any country. Suppose I put here this name about that Saudi Arabia. So now I can get this NDVI map of Saudi Arabia. Okay, so any country can simply put the name, then it will be work. Suppose I put here that Colombia. So now we can get this NDVI map of Colombia. Okay, so now it shows the NDVI map of the Colombia. So any region in the world, just you have to import your shapefile and then click with your shapefile. Now we can get the NDVI map about that. Okay, but this NDVI map have a problem. What's the problem? This problem is that here you can see when I click on the inspector tab and click on this NDVI map, then I can get this type of result. I can get that 5,420. When I click on here, then I can get this type of result, negative 1,000. This type of result I can 32, but it not show me the proper pixel value. Okay, basically what is the range about the NDVI? NDVI range all time -1 to +1. This is the range about the NDVI. You can simply search on the Google, suppose NDVI range. Here you can find out the range about that is that +1 to -1 all time. Okay, but in this time for my Moody's data set, it show me the result is not reprojected. Okay, so in this time anyhow I need to reprojected this scale value, so that's why I can get the result +1 to -1. Then I can get the proper NDVI map. And also you can see about that NDVI values range from +1 to -1, and mainly areas of the barren rock, sand, snow usually show very low NDVI values. For example, less than 0.1. Sparse vegetation such as shrub, grassland, or we can make result in moderate NDVI. We can get the 0.2 to 0.5, and high NDVI values approximately we can get the 0.6 to 0.9. Okay, but in this time my NDVI map show this type of value. Okay, so in this time I will show you that how we can easily reprojected the NDVI value. Okay, and basically all time you are applying the same, suppose other data set, not only for the NDVI. You can see in our Moody's it also provides a lot of data set. Okay, we are also use the same process for the reprojecting. Other you did not get the proper result. Suppose here you can see I just try to open this land surface temperature data or any data. Suppose here you can see that gross primary productivity data. Suppose you can see simply open this data. Basically it's another data, it's used for the gross primary production, GPP. Here you can see it also have the this data set you also need to reproject it. Okay, so any kind of data and how you can get the reprojected value. So basically which data set have a scale, you can see the scale 0.01, also you can see 0.01. This type of data you must need to reprojected this scale value for getting the proper pixel. So in this time we are using the Moody's NDVI data, and here you can see Moody's NDVI data also have a scale. Okay, so this scale we have to use, and then further we have to make the reprojected our scale value. So just I open this data. Yeah, so simply click on here. Here you can see this data have also a scale. Okay, in this time we have to use this scale and then make the proper pixel of NDVI +1 to -1. Okay, so now let's check how I can apply the scale. In this time this scale value I need to multiply total 23 images, mainly my image collection. I need to multiply all of images with my scale factor 0.01. Okay, so now how I can multiply, it's very important because in this time it has the total 23 images. I need to multiply with my scale factor 0.001. This value I need to multiply. So in this time we have to use the concept of function. Function mainly we are used for reuse our code and make it easier to read. Suppose in this time I create a function. This function help me to at the same time all of image multiply with my scale factor. This function helped me. So let's check how we can easily create this function. And before that, if you have any question, you can ask me. Anyone, any question from this code or any confusion? Okay, I think there is no problem. Okay, so in this time we talk about the how we can easily make the reprojected the scale factor.